Geometry has a lot to do with shapes and the special properties that we know about shapes. So in section 1.1, we're understanding points, lines, and planes. The objective of this section is to identify and draw points, lines, segments, rays, and planes, and apply basic facts about points, lines, and planes. Undefined terms. This is a vocab word. There's really not much about it besides the fact that it's the most basic figure in geometry. They cannot be defined by using other figures, and it's the building blocks of geometry. A point. A point names a location. It has no size, and it's represented by a single dot. All geometric figures consist of points. So if we have, the notation for a point is a capital letter. This is extremely important. Highlight it, circle it, remember it. So if we have a point here, we would call this point A. If we had point A like this, a lowercase a, that's not a point. We can't call this point lowercase a. It just has to be capital. So this is not a thing. It has to be capital A. In algebra, you guys dealt with points. When you had coordinate planes, you guys have all seen a graph, right? You graphed points, and you connected them with a line. Have you guys seen this in algebra? Okay. A line is a geometric figure consisting of at least 2 points. It extends in 2 directions without ending. It has no thickness, and its notation is 2 points on the line. So this line, so it can be called 2 points on the line. In this case, this line would be XY, and we would have to put a little line on top of it. Or this can be called YX. These mean the same thing. XY and YX are both names for this line right here. We can also call a line by the lowercase letter. So just one single lowercase letter. So in this case, this would be line L. Right, so we have line L, XY, which all of these are talking about this line right here. Any questions this far? Okay. Now we move on to planes. Planes are a geometric figure that is a flat surface extending in all directions without ending. It has no thickness, and although it has no edges, in images it's depicted with edges. So in this picture, you can clearly see that it's a box. It has orange edges. But in reality, planes extend on forever and ever. So it's a flat surface. It would be like this piece of paper, a flat surface, but it extends on forever and ever. Okay. So the notation for the plane would be a capital cursive letter. So this one, we have the R in the corner. So this could be plane R, like it is here. Or it could also be named by 3 points in the plane that are not on the same line. So 3 points here, A, B, and C. So we could also call it plane A, B, and C. So it can either be called by a cursive capital letter or 3 points in the plane. Okay, more vocab words. Space. Space is the set of all points. So if we had a triangle, the set of all points of this triangle would be the points that make up this triangle. So all of these points on the triangle. Collinear are points that lie on one line. So if we had point A and point B and a line that connects them, A and B would be collinear because they lie on the same line. If we added point C up here, C would be non-collinear because it does not lie on the same line. The same concept is for coplanar. If we had a plane here and we had 3 points, so this is plane ABC, point A, B, and C are coplanar because they're all on the same plane. If we added point D up here, D would be non-coplanar because it's not on the same plane. You might ask, but what happens if you said a plane extends on forever in all directions, so then wouldn't D be on the plane? But if you had a plane like this sheet of paper and you had a point up here above it, this is point D, it's not on the plane. Points on the plane would be points on the paper. Okay? So a point not on the plane would be point up here, over here, down here, not on this plane. Line segments. The part of a line consisting of 2 points and all the points in between them. It is noted by the 2 endpoints. So in this case, we would have line segment AB, which we would put a segment on top of it, or it could also be called BA with a segment on top of it. You can switch, you can call it AB or BA because the distance from A to B stays the same if you're going from A to B or from B to A. It is the same line no matter what you call it. The end point is a point at one end of a segment or the starting point of a ray. So we haven't gotten to rays yet, so let's just look at the top one. This, we know it's called CD. Segment CD. Yes, go ahead. So an endpoint of this segment would be C and D. So this segment has 2 endpoints, which is where it stops here and where it stops here. So the endpoints are C and D. We're going to come back to the one on the bottom. A ray is part of a line that starts at one point and extends on forever in one direction. So a way to think of this would be if you had a sun, and we draw a sun like this, right? The sun emits rays of light. I know, this is math, not bio, but the sun emits rays of light that go on forever in one direction. So it starts at the sun, and it is going on until it reaches Earth, right? So a ray starts at one point and extends on forever in one direction. So we would name this ray by its end point and a point it contains. So the end point of the ray would be R. The end point would be R. And a point contained in the ray would be S. So for rays, you have to put a little ray on top of it. But it's important that where it starts, so like the R, is where the arrow is above, it's where the arrow is here. Okay? What would the ray on the bottom be called?
RS.
It would also be RS, because look, it starts at R and goes through S. So it's important that the arrow, it's over here, that's on top of the S.
Why would it not go on the left?
It doesn't.
Well, like, why?
It's a good question. It always needs to point in the right direction when you're naming a ray. So you can't have, say you wanted to call this SR and point the arrow that way. You cannot. You can't do this. Okay? It's a no-no. It always has to be facing the right. A ray can point whichever way it wants, but when you're naming a ray, it has to point to the right. It's like when you're reading. You start left to right. Okay? Opposite rays. Two rays that share an endpoint and point in opposite directions. So here we have ray EF. Let's use red. Ray EF. So it would start at E and go through F and point to the left. And then we have ray EG, which starts at E and points to the right. So these two rays share an endpoint, which is point E, right? They share this point. They share the endpoint E. And they point in opposite directions. Opposite rays form a line, okay? And lines, we know, have to be perfectly straight. So this, if we had a point here, and a ray here, and a ray here, these would not be opposite rays because it doesn't form a straight line. That's not a straight line. Lines have to be perfectly straight. And these don't point in opposite directions. They point in different directions, but not opposite. They have to be completely opposite. One has to go left, one has to go right, one has to go up, one has to go down. Opposite. Dashed lines represent hidden parts of a figure. So if I had a piece of paper, everybody look this way, and I poked a line through it, this was my line, this is my plane. If I held the plane like this, you can't see the bottom part of this line, right? It's hidden. But it's there. It's there. There's a line there. But it's hidden. So a dashed ray represents what's hidden from the plane. So you see that this part here that's dashed is behind the yellow plane. So in this picture, you can kind of tell that this red line, the one that's not dashed, is above the plane and then kind of behind the plane. And then you have a box, which I'm sure you've all seen a box drawn before. This part, the dotted lines, are the parts that are in the back of the box, so it's hidden from view. Okay, example 1. Can anyone name lines in this picture? Joseph?
AB.
Right, we have line, AB. What's another one?
AC.
AC. So right now we have this line, AB, and AC. What's another one? Yes.
CB.
CB. What's another one? Yes.
CA.
So CA, if I go from C to A, we already drew that line, right? So CA is the same thing as saying AC, which you could say CA on a test. But if I ask you, what's the number of lines in this picture? The answer is 3. For each one of these, you can flip. You can call this one BA instead of AB, but it would still be talking about the same line. Okay, let's go back to the picture. What are the rays in this picture? Yes.
R.
R is talking about the plane, right? What's a ray? A ray has one endpoint and extends on forever in one direction. There's no rays. Was that what you were going to say? There's no rays in this picture. We don't have one endpoint and a line that goes on forever. All of these in this part, we all said these were lines. AC, AB, BC, those are all lines. So those can't be rays. What are these down here? What if we had K, N? What's that? A segment, because it has 2 endpoints. So there are no rays. What about planes? Yes.
R.
Yes. We have plane, which is called plane R. What can we also call plane R? This can also be plane KNML, right? Because it's more than 3 points that are in the plane. So we can call this plane LMKN. But this is just one plane. These are 2 names for one of the planes. What's another plane in here? Yes.
ABC.
ABC. And we can call this plane ABC. So let's look at the first plane. Plane R. What are the coplanar points in plane R? Yes.
Because they're not like on things that
No. Yes.
all of them.
All of them. So the coplanar points are K, N, M, and L. Yes. Go ahead.
How come are they closements? Like, how come?
Because they're all on the same plane. So this here, can't really see the red through it, but this is one plane. And K, it's the corner of the plane, but it's still a plane. K, N, M, and L are all on the plane. So they are coplanar.
Oh, okay.
So when we're talking about plane R, K, M, N, and L are coplanar. What about when we're talking about the second plane, plane ABC? What are the coplanar points there?
Is it A, B, and C?
A, B, and C. 3 points on the plane. Draw a segment with endpoints M and N. So we need an endpoint here, M, and an endpoint here, N, and a segment that connects them. If I asked this question on the test, I would see 30 different answers because you could make the segment like this, M and N, or like this, M and N, or N and M. There's many different ways to draw this. I just need to see that it has 2 endpoints, M and N. Draw opposite rays with a common endpoint M. So we start with the endpoint M, and we draw one in this direction, and the other one has to be in the opposite direction, making a straight line. Draw and label MN. So this, we know that our endpoint is M, and the ray goes through N. Any questions? Yes. Right. You could draw, if you labeled MN, you could draw M here, and you can draw N here. Or you could draw M here and N here. There's many different ways to draw it, just as long as the endpoint is M and it points in the direction of N. Name a line that goes through the point.
Line XY.
Don't forget the little line on top of XY. What's another way to name XY? Somebody different. Come on, guys. Allie.
YX.
YX. Name the plane. We're talking about the orange one now. Yes.
R or G, H, F, B.
Yes. So it would be plane R or plane G, H, F. Yes.
So if a plane doesn't have the cursive letter, it's just going to be the point.
3 points in the plane. True or false? Line PF ends at P. True or false?
False.
False. Because a line, if you had line P, F, a line extends forever in both directions, right? So it has no ending. Point S is on an infinite number of lines. True or false? True. If I had point S here, I can draw a line going through it this way. I can draw a line going through it this way. A line going through it this way. A line going through it this way. So this would be true. A plane has no thickness.
False.
This is true. Planes, lines, and points. If you go back to the slides for each of those, the second bullet point all says has no thickness. All of them have no thickness. Okay? It is a flat surface. We use a piece of paper to demonstrate it, but this wouldn't be a plane because this has thickness. A plane has no thickness. Collinear points are coplanar.
False.
False. Because if you had, let's take this piece of paper again. If you had a line that goes through it, if I take a point here that's on the stylus line, and a point here that's on the stylus, these points wouldn't be coplanar. So not necessarily are collinear points coplanar. Sometimes they can be. If I took the line and put it like this on the plane, these points would be coplanar, but not always. So this would be like a sometimes, okay? So sometimes true, sometimes false. Because collinear points can be coplanar, but not always when it's like this. Because you could have a point on the plane and a point above the plane that are collinear, but not coplanar. So this one we could put sometimes true. Planes have no edges. Planes have edges. True.
False.
It is false. Planes have no edges. Planes extend forever in all directions. Okay? If you had this floor as a plane, it would go forever into Mr. Harichi's room down the hallway. Forever. Forever that way. Forever that way. Forever that way. Okay? Points have no size. True. If you had a number line, and this was 1, this was 2, this was 3. You guys have seen a number line, right? And you're talking about point 2. A point that lies on 2. This point wouldn't extend to 2.01 and 1.99. It's just 0.2. It has no thickness. Line XY can be denoted as XY or YX. True. Ray XY can be denoted as XY or YX. False. It would only be denoted as XY because the endpoint is X and it extends through Y. This one would be saying that it ends at Y and extends through X. But we're talking about ray XY, so it has to be this one. Has to be this.
Would it just be denoted as X?
Point P is in M. So let's look at P. P is down here, and M is this box. Is P in M? No, so it would be point P is in, so this would be false. B is in M. So let's think, what's B referring to? B is talking about this line, right? Because it's a lowercase b, and the only thing that gets a lowercase letter is a line. So is this line in M?
No.
Why do you say no?